Now that we have defined area of any planar region and connected with congruency of two figures in brief, now let's see how we are going to represent area, because we're going to solve many problems where areas are involved. Now comes the question on how do we represent area of a closed region. Representation of area is the session about. Representation for area. Now let's take this is the region, say of the planar region. Now I would like to find area of this region. Now how do we represent this region with area? If this is represented by A, this whole region is represented by A, then area of region A is denoted by area of A or AR of A. So simply when I write AR of A, that implies it is the symbol or representation for area of A. So area of region A is denoted by AR of A. Similarly, if I take a triangle ABC and I take the height and the base to be 5 and 2 centimeters, then to find area of this triangle, for example, with altitude as 2 centimeter and the base is 5 centimeters, then area of triangle ABC is denoted by area of triangle ABC. Is how I denote this. Area AR of triangle ABC implies area of the triangle ABC as denoted with this region. Is how I understand area of the region, which is nothing but half into base to height, 5 centimeter square. Therefore, area of triangle ABC is 5 centimeters square. Is the representation when you find area. Finally, I represent the answer with AR of the given region. This region is triangle ABC. This region is A, which comes here. AR of A implies area of the entire region A. Is how I understand the representation for area of any given region. Now that we have defined the representation for area for the region A being AR of A, let's see how we can connect this with congruency of two figures. So as the representation is understood for this region A, I have the property which says for congruent figures A and B, say I have two regions A and B which are congruent. For those congruent figures A and B, I understand the property as AR of A is equal to AR of B. Is how I understand the congruency. For congruent figures A and B, AR of A equals AR of B, because when two figures are congruent, their areas are equal, their sizes are equal, their shapes are equal, and hence AR of A equals AR of B, the representation of area for congruent figures. Now that we have defined the representation of areas, now let's see how we can connect non-overlapping planar regions connected with the areas. Suppose we have non-overlapping planar regions. The session non-overlapping planar regions. Let's see what are non-overlapping planar regions. Now here the word overlapping in the sense trying to join the two planar regions without overlapping each other. So let's see in brief the non-overlapping planar regions. For example, I have these two regions which are separated here. So I have two regions here. This is region A, which I denote with say some P, and this is region B or region Q, which I denote. So I have two regions here. This is region 1 as denoted by dots, and this is region as denoted with this. Now I have two regions. The first region region 1 and this being region 2. Now these two regions are joined together such that they do not overlap. Now the planar region 1 denoted by P and the planar region Q denoted by planar region 2 denoted by Q are now joined together, where the whole region joined is denoted by T. If T is the total planar region, if T is the total planar region which joins both P and Q, which joins both the region 1 P and the region 2 Q without overlapping. One of the most important thing is that the planar regions do not lose their area when they are joined. They are non-overlapping. So this plays an important role. Without overlapping each other. Now here T is the total planar region which is obtained by region 1 plus region 2. Then I have a mathematical property which connects area of the whole total region T denoted by AR of T will be equal to area of the region P, that is the first region, plus area of the second region Q. So if I join the two regions, implies area of P plus area of Q equals area of the entire total region T. Is how I understand the total region. Area of T equals area of P plus area of Q. So T the total region which joins both P and Q, then area of the total region will be area of the two regions which are joined without overlapping each other, which plays a vital role. non-overlapping planar regions denoted with mathematical equation AR of T equals AR of P plus AR of Q is how we understand the concept connected with planar regions.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.